Alrighty, forensics students. So today's lab is going to be found in your lab book on page 45, page 45. So open up to that page. Everyone in the class will be open up to that page. Now, if you were absent, not zoomed in, not here in class, I will tell you, you really need to read this introduction. I am not going to do that for the video because you can read, take out some of the specifics. The one thing you need to pay attention to is the structure of the drugs. Okay, so when you read, pay attention to the structure. They ask you what's similar and what isn't. So if you look at some of the structures over here, what is similar, this is called a ring structure. They all have these ring structures. They all have things off of the ring. What is different is what's off the ring. So when you get to the questions ask you about the reading, not so much about the observations we're going to make, but it asks you about the reading. So you have to read. You can't bowl off the reading. It goes through all the drugs. Here's acetaminophen, and they ask you about acetaminophen. Okay, it's like Tylenol. Here's ibuprofen. Then it talks about antacids. So you have to go through and read this and look at the differences in the structure. Notice nothing here. This has this. This has this. Okay, bigger group. Different type of group too. Right? They all have things that have this double bond O in it, but the stuff attached is much different. Right? This has an extra thing here. These do not. So let's pay attention to that. But you need to read to answer a lot of the questions. So we're going to look at how over-the-counter drugs behave, how they can be classified by chemical experimentation. Right? So when you do this lab, and I'm actually going to get another book out. So I have my procedure out, and then I have my data table, although I know the procedure, but I want to show you the procedure as we go along. So let me grab another book. So we are going to be recording data on page 51 and 52. So I'm going to open this particular book up to 51 because this is part 1, so we're going to focus on 51. So on page 51, we are going to analyze these different pain medications. And with those pain medications, and I may even take this out because it's really a pain to write on it in the book, we also are going to have unknowns. You choose the unknown. I'm going to do all of the unknowns. You choose it. Make sure you write it, the unknown letter, because it's really a letter. Because if you don't, I can't give you credit for identifying your unknown. This is one of the labs where you have to make proper identification of your unknown to get 100. All the rest will be like 90%. It'll be like 1 point of your lab or 2 points of your lab. Depends on whether I do this out of 10 or 15 or 20. Usually this lab is done at least out of 15. It's a long lab. Okay, so we're going to be working on this. In fact, I'm going to take this data table out of my lab book just because it becomes easier for me while I record to write on it. There are questions that follow the data tables. All right, so looking at, and you might say, gee, we skipped a lab. Yes, we did. I have a new lab, and it's a longer lab, and it goes into more depth. So this is to introduce you to doing these kind of observations. All right, so the first thing I'm going to do is, if we look at these directions, and for those of you in the classroom, we'll go through this, I'm going to follow this particular thing. I'm going to crush the different pain relievers. I'm going to put a few of the granules in the columns, and then I will add all the pain relievers to the table, and then we'll start doing observations. When we go to do observations, one of the first things we do is we just observe and describe its identity. Like, what does it look like? And then we'll look at, is it soluble in water? And then we'll test it to see, what kind of pH does it have when it dissolves? Now, guys, when you do solubility in water, if it is clear, we say it is soluble. It means it dissolves. If it is a little cloudy, we say it is slightly soluble. But if it's unchanged and it remains on the bottom, we say it is insoluble. Okay, so those are the three things we say: soluble, slightly soluble, or insoluble. We will test pH. Like I just said, we use two things. We use the universal indicator, and I'm also going to use a pH paper because the universal indicator doesn't have a really good range on pH. The pH paper goes lower, so we'll do both. And then it says dip a strip, so that you can see there'll be a color change, and then we're going to do the strip. So we're going to actually split some of the observation cells in half. After we do that, we are going to add acid to it to see whether or not the material reacts. One of these is called bufferin, and that has what's called a buffer in it to make it a little more better tolerated by your stomach and not as acidic. Because when you read, it tells you when it's too acidic in the environment, the drugs don't get absorbed as well. Right? So this one actually contains a buffer in it so your stomach doesn't get very acidic. So we're going to test how it reacts with acid, because if it bubbles, it means that it can counteract the acid. And then we're going to react it with nitrate, right? Iron 3 nitrate. Once I do these 5, I am going to do all the unknowns, and you choose. Okay, so your unknowns, I believe, I got to get them out here. You have a choice up here. You can either choose A, unknown C, unknown D, or unknown F. You choose one. So you're going to watch the results, and you're going to decide which one am I going to record the results for and identify. Okay, so you get a choice. Usually you come up and you pick one out of a bag, and that's the one you have to do. And then we'll stop there for today, and then we'll do the antacids as part 2. So let's start off. I have to go get my little chemicals. Okay, so this is my aspirin. There's aspirin tablet on it. You take out one. It has a smooth finish, so you're doing your observations. Oh, and I have to get that up too. So I have my little well plate that I'm going to react and use. All right, I'm going to put aspirin here, acetaminophen, ibuprofen, bufferin, excedrin, unknown A, and then below it I'll have another table where I'll put unknown C, D, and F. Okay, now I'm a little constrained with space here, guys, so I'm going to be moving things around a lot. It's just if I move my computer, then I don't have it linked, and it's a mess. Right, so let me get my recording pen. We are going to take this top row, and we're going to divide it in half. So take your data page and just put a line halfway through each cell. Okay, we are going to do the same thing here. We're going to divide it in half. And we're going to go back and say, well, what are we observing? This is where we write our observations. So you're going to take a picture of this page and upload it. This is one of the pages. You're also going to take a picture of this page and upload it when we get it finished. And then you're going to take a picture of the next page, which is 53. Those are the 3 pages you need for the lab. So up here is appearance. So this is part A, and this is part B, all the way across. All right, A, B. Again, all the way across. Appearance on the top. So we are describing pre and post grinding. So for aspirin, I said it's very smooth, it's small, it's white, it says aspirin on it. Okay, if I crush it, because I have to crush it, I have to tell you how it behaves. It crushes fairly easily, and it makes a white powder. Now I'm going to take some of this white powder, and I'm going to put it in each of these wells. You don't need very much at all, so I'm going to use this little scoopy thing, and actually I might go get a different one. It's not too bad. And I'm going to go down, and I'm just going to fill them, and it'll give me an extra well. I just don't like to work on this, so I'm going to do it this way. I only need a few grains in each well, not very many. Okay, so there's aspirin done. Put this aside and get my next one. The next drug is acetaminophen. Where are you? Here you are. Acetaminophen tablet. Okay, this is more like a capsule. Again, it's very smooth on the outside. It's kind of hard. It's a little off-white. Oh, this crushed easily. And crush up my acetaminophen, which is Tylenol. I'm going to try to make it really small, because the smaller the little particles, the easier it is to evaluate whether it's soluble in water. Okay, this is a bigger pill, so I get more powder than what I did on the aspirin. I get another different scrupula out. So this crushes more easily, I would say. The powder that I'm getting is finer. And I'm putting some in an extra well, just in case I want to retest anything. So this is my acetaminophen. The next one's ibuprofen. This one has a different color to it. So this is like a brown, reddish brown color. Also smooth. I'm going to crush that one. It says I on it. Oh, this one's harder to crush. And if I crush it, I don't know if you guys can see that. You have little red flakes in there from the coating. So this is coated, and the flakes from the coating still stay brown after you crush it. Oops, wrong one. Coated. And it stays brown flakes after crushing. Okay, the powder itself is white, but the coating stays brown. All right, which one's that? 3. So I'm going to put this in the third well going down. I'm going to try to get both the powder and the external coating, because the coating probably is just something that makes it easy to swallow. It doesn't have the drug in it. So I'm getting both in there. And again, I don't need very much, just a little bit of powder. Because if you have too much of your material, what ends up happening is you can't see whether it dissolves. You might actually have to get a black piece of paper to put under it too. Okay, we have bufferin. Bufferin's a bigger tablet, has a big B on it. All right, so this has a big B, larger tablet. It's smooth. Let's see how it crushes. It's very easy to crush. It's not as hard as the other tablets. It doesn't seem to have a really slick coating on it. It gets really fine when you crush it. The aspirin was hard to get fine. So again, I'm just going to sort of just corral a little bit of material into each well. I know it's kind of hard to see because the materials are all white and the paper's white. So we're going to probably be going back and forth between a white and a black background on this. And our last one that I have to crush, actually I really should have my safety goggles on in case any of the medicines pop up into my face, is the Excedrin. Now the unknowns are already crushed because a lot of the tablets have identifier marks on the outside. You can see the bufferin had the big B. The Excedrin has its pharmaceutical number, which I don't think you can see no matter how I put it. There's a little pharmaceutical number there. You can look up drugs in what's called the physician's desk reference. Now it's more a digital thing. It used to be this huge book. You can look them up by that number. They're on file with the FDA so that if you see a pill and you don't know what it is, you can take the pill. Sometimes now with some of the apps, you can take a picture of the pill and you can ask the app to find what kind of pill it is. So we'll put the bufferin in here. Remember, the bufferin's this one's Excedrin. The bufferin that I did, the other one, is supposed to have ability to calm your stomach acids and make sure the material doesn't turn acidic as it sits on the shelf. Okay, now, I have unknown A here. Okay, so let's do this one first. This was white. It was, I'm going to say thicker than the others because it was thicker, like higher. And then when you crushed it, it was a fine white powder. And the bufferin wasn't as hard to crush, but the Excedrin was about the same as the other ones. But this was easy to crush. So under the bufferin, I'm going to put down easy to crush. If you have big handwriting, it's hard. This company sends out data tables like this, and I haven't had a chance to modify the data table. So it'll be a little difficult for you to get all your observations in. So you have to try to write as small as you can. So this is unknown A. Flaky powder. A little chunky in there. Seems to have picked up moisture. Okay, so I'm just going to leave this right near, and then I'll put the other table together in a second. All right, so for this one, it's flaky. Oops, I forgot the E. Looks like it's picked up moisture, meaning it's a little chunky. It's white. There's no color in it. So by appearance, I don't think it's ibuprofen because there's no colored flakes. And now we have to do solubility. So I'm going to take my water bottle. Now guys, when you use water bottles in the lab, you keep the water bottle upright. And then you don't tilt it because the bottom of the tube goes down to the bottom of the water bottle. There are water bottles you can buy that have a different type of outlet, and then you would tip it. This one you don't tip. You keep it straight up and down. We're only going to put water in the top one. And even if I put a little water in the one below, it doesn't matter. So I'm going to fill them halfway. I'm going to try to fill them the same amount. Ooh, that outer coating is floating. Okay, so I've added the water. And actually, guys, for the color with the universal indicator, I'm also going to add water here because without the water, you're not going to see much. So I'm just going to add a little bit to get it into solution so the indicator can change color or the pH paper can pick it up. We won't do that for the third row. Okay. So now I'm going to look to see, did it dissolve? So I'm going to take a black piece of paper. This one is bubbling as it dissolves. So I think that's the bufferin. So the bufferin is bubbling, like really bubbling. I'm going to have to take my goggles off. I'm going to move this down a little bit so you can see a little better. Try to focus in. There's a lot of glare, guys. That's why I hate doing labs like this. And I'll try to use the other camera as well. In the end, you can always freeze it. I'm stirring. That is not going into solution. There's a lot on the bottom. I flipped it over, by the way, from well to well. I did not put the same end in. Okay, so this is interesting. The little colored pieces floated and then dissolved, but the actual white part of the drug is floating on the top. These sink to the bottom, that floats on the top. Okay, flip these over. This is slightly soluble. It's cloudy. And it's still bubbling. Interesting. The excedrin also is slightly soluble. It starts to get cloudy. And unknown A. Ooh, no, it's not soluble. It's acting like the first two. Okay, so solubility. That's B, part B, the bottom of the wells. So for A, unsoluble. B, insoluble. This one's partly. The coating dissolves. This is partly, it gets cloudy. This is also partly, it gets clouded. And this is insoluble. Okay, so I'm going to do pH paper stick first, and then I will do indicator. Because the indicator can sometimes change what happens with your pH paper. Now guys, I don't need a lot of pH paper, so I'm going to take my pH paper and rip it in half to save on supplies. And I'm just going to dip it in and pull it out. Okay, so if I dip it in and pull it out, that looks pretty pink. pH of 3. Going to the next one. Ooh, yellowish. 6. The ibuprofen. Put that in. 5. Let's look at the buffering. It's supposed to buffer, so it should be closer to neutral. I'm going to use 6 on that. Excedrin. Ooh, that's really acidic. 2. Almost a 1. That's going to be tough on your tummy. Excedrin's for migraines. And then unknown A. That's like a 3. Yeah, I'll go 3. Now I'm going to put in the universal indicator and see what color it turns. It should be similar in color to your pH paper, but it can taint your pH paper's results. Swirl it a little. Okay, so this is looking in terms of intensity about, that's like going to be a pale red. That's going to be a yellow, which is more a 6-7. This is orange, which is like a 4-5. Right, so when we look at our results, this is a pale red. That is around a 3. This is a yellow, which is around a 6 to a 7. This is an orange color, which is around a 5 to 6. This is a reddish orange. Which is again a 5-ish. This is pink. And this is a pinkish red or a light red. And this is around a 2 to 3. Same as this. Okay, we have one more. Well, we have 2 more. Sorry, you have to react it with HCl. So we're going to take each one of these and we're going to add some drops of hydrochloric acid to see if there's a reaction. Okay, and then also you look to see if it dissolves any more than up above. And again, I will do the other unknowns in a second. So I'm just covering the bottom of the well. Oop, that's bubbling. Whatever number 1, 2, 3, 4 is, it's bubbling. I don't know if you can see, it's all bubbling around the edges. Okay, the last 2 aren't doing anything. I'm just going to see, does it dissolve anymore? So I'll take some toothpicks and just swirl around in there to see if the acid has it dissolve any better. Again, I'm flipping it over. If these were really unknown and I didn't know they were over-the-counter medicines, I would use a new toothpick and not touch the solution. But I know that they're over-the-counter medicines, which we take and we ingest, so I'm not worried about touching them after they're powdered. I will definitely wash my hands. I hope not, I'm recording. Again, it doesn't look like there's a huge difference in it dissolving, but the only one that really seemed to show any type of reaction was number 4. Number 4 really bubbled. Okay, so the rest of them don't look like they're really different. They don't look different in how they dissolve. This one over here is weird because I added the acid and it looks like it's cloudy. So that's not acting like how I expected it, because the first tests acted a lot like one of the other knowns. So this is kind of different. And that has a more of a film on the top. So with the acid, that has a bigger film, and that bubbled. But none of the rest really did anything. So this was no reaction. Oh, and I have to double check its pH. Told you the pH paper. This was no reaction. This has a film on the top. This bubbled at first. And it's cloudy. This was just cloudy, no reaction. I don't see any bubbles. Cloudy, no reaction. Now I'm going to do another quick check on pH to see if there's a big change. A lot of them might just be very acidic. And this may not work because if the material that's supposed to neutralize the acid has been around a long time, and these have, they've been sitting in bad conditions over the summer because they don't keep the conditions. These are going to be really dark. So that's like a pH of 1. That's the first one. Second one, that's a pH of 1. Third, that's a pH of 1. This is the one, well, does it have a different pH? Not really, and it should, but I think it's just I don't have very much material in there, and that's why. So I think all of these are going to be a pH of 1. And none of them really buffer very well, meaning I add acid and it keeps the pH the same as what we started up above. No, they're all pHs of 1. So none of them really buffered well. Probably if I put a ton of the buffering in, you'll see a difference in the pH. And then the last reaction is the reaction with the iron. So we're just going to see if there's color changes. And then I'll do the other 3 unknowns, and I'll leave the unknowns side by side. Ooh, that turns purple. The little flecks of the material are turning purple on that first one. This one's turning purple. This one does not turn color. That's got a mixture. There's purple in there, but not a lot. Oh, that turns deep purple. And this one, just a little material turns purple. Okay, so the material turns purple like the clumpy material, and we get a fresh one. So that's a light purple. That's a grayish purple. That's yellow. This turns brown. A little bit purple, but mostly brown. Let me get another one. This is very purple. Like deep purple. And this is a light purple. Okay, so here it looks like the solution's clear and the drug itself, like the powder, turns purple. On this one, it's like a grayish purple. This stays yellow, so I don't think there's any reaction here. This is almost like a ruddy brown. This is a deep purple. And that's sort of like a light purple. All right. So when we look at these unknowns, and I'm going to do the other 3 unknowns in a second. When we look at these unknowns, you're looking at how well does this row match up with a row here. Okay, so the first 5 rows are your known material, and then this row has to match up with someone here. So I'm going to do the other unknowns. Okay, so we have unknown C. Oh, unknown C has those red flakes in it. Kind of a giveaway. Unknown D, very grainy powder. And I'm just going to verbally tell you what I see. I'm not going to fill in another data table for you. So unknown D was a real fine powder once it was ground. And unknown F, let's see what those one looks like. That's also pretty powdery. So A was chunky. C was, what am I looking for? Had that outer coating that's pink. And D was very powdery, and F was very powdery. Let's look at their solubility. Again, I'm just going to pour, and then we'll stir over the black paper. So I'm going to squirt water into the 2 cells, the first 2. So I can do pH. I'll get the black paper so you can see how well it dissolves. And then I'm going to hold them close to those so you can see in the end what they look like. I'm also going to stir this one up a little too. Okay, for C, it looks like the coating is dissolving and the other part is floating. B doesn't look like it's dissolving. It's sitting on the bottom. And not B, I'm sorry, D. This is D. And F is slightly soluble. It gets cloudy. All right, so let's check the pH. Leave it in there a second. Oh, that's very acidic. So if you are recording D, D is like a 2-3. I'd go with a 3 on that. F looks like a 5. This is a 3-4 for C. Might be something in that well. I'm going to try a different well. Okay, C. Its pH is also looking like a 5. Put the indicator in. I'm going to put in this one. I'm going to do both so I can see if I don't have something contaminated, like there's something in that well. It's a problem with reusing the weld plates. So this is like the indicators a pinkish red for C, a pinkish red for D, and an orange color for F. All right, I'm going to add acid to them and then redo the pH. I bet you they'll all be 1 though, guys. This one's bubbling. F looks like it's bubbling. So if you're recording unknown F, that's a bubble right here. Okay, pH is 1. 1. Also 1. I'm going to let them sit a little bit. I'll go back and test those pHs again, because over time the pH might change if anything gets neutralized. That one stays yellow. Okay, they should be reacting, and they're not. Sure, I love it when science doesn't always work out the way you think it will. C's definitely not reacting. It's staying yellow. Let's see what happens once I stir this up. That's kind of starting to turn brown. I might not have enough material in it, so I may add a little material to that. Let me not contaminate. Let's get some more of these. Oops, sorry. Now that was unexpected because I really expected that to turn color. Okay. Now go back and retest our wonderful pH on these with the acid. Nope, still 1. Still 1. Still 1. Okay. So none of them are working very well to control pH. All right, so these are our controls. Yeah, can't really get them both. Let me go up. There we go. Now you can kind of see them all together. None of them match up perfectly, so you're just going to try to pick the one that you feel you can match up the best. Right? So remember, this is aspirin, acetaminophen, ibuprofen, bufferin, Excedrin, and then we have our unknown A. This is unknown C. Okay, this is unknown D. And this doesn't look the same because remember I double tested the pH. So you're looking at these 3 wells. And then unknown F. Unknown F is not matching up very well at all. I really expected unknown F to look more like bufferin because how it bubbled. But the bottom isn't turning brown like the bufferin did. But choose the one that works best for you, one of those 4. You can pause and really look at the material. So you're going to finish filling out that data table.